Let's look at a paleoclimate example before we go on to look at what we would call natural variability, and then we will get into response to anthropogenic or human perturbations of climate. I did mention abrupt climate changes in the context of ice albedo feedback about how the melting phase goes really fast. This is a good example of Greenland temperature record from Greenland ice cores. I think it's Epica, one of the domes that I don't not. Let me be careful. One of the ice cores from Greenland. About 18,000 years ago or so, the glacial melting started. The last glacial maximum happened around 21,000 years ago, and you can see that this is shown in terms of the delta O18. And remember, when it is highly depleted, then it is obviously colder because O16 is getting locked into glaciers, and you can see an abrupt warming. So these are warmer temperatures here and colder temperatures here with respect to the present day global warming. We have to be careful. I'll explain this again. It's not like we are not in global warming, but the temperatures were colder than present, and then we have been cooling over some time, and then there is warming here, which is global warming. This is Greenland, so we have to be careful about which temperature record we are looking at. Nonetheless, this warming abruptly stopped and started going back, and cooling happened in what is called Younger Dryas, and then the warming picked up again at the end of the Younger Dryas 10,000 years ago, 11,000 years ago, and then we got into what we call the Holocene, where we are now replacing this with the Anthropocene. Exactly where it starts has to be established by the geologic methods of finding evidence in the earth, because that's how ages, geologic periods get defined, right? So why did this rapid cooling happen? And you can see that these hiccups are of the order of a century or 50, 60 years, and sometimes even just few years. So there are these hiccups possible, and this talks about Gulf Stream shutdown. What does that mean? So we talked about the Gulf Stream and it's bringing warm waters here and creating evaporation, dense water formation, etc. So when the last glacial maximum started, and the ice that was several kilometers thick and had extended down to Long Island down here and over much of Europe, started retreating, and that's what carved out these Great Lakes and so on. And when the melting happened, apparently there was an ice bridge which prevented Lake Agassiz, which is up here somewhere, from releasing the meltwater into the ocean. And at some point the ice dam broke and released massive amounts of fresh water into the region where evaporation and the salinity left behind can form deep waters. If you put a lot of fresh water on top of it, evaporation will not be able to produce heavier waters, even if it's leaving behind salt, because you just put too much fresh water on top. Okay, that's one of the explanations we have for this, and that highlights the sensitivities our system has in terms of perturbations to the thermohaline circulation because of human activities and greenhouse gas increases. The other point to note, of course, is that the temperature variability over here is order of 1 degree. And they still had perturbations in various civilizations, and as we mentioned, the colonization of Greenland by the Vikings during the medieval warm period, the Little Ice Age, which froze the Netherlands and created problems for England. England, which used to produce wine, became too cold and went to beer, and I don't think has gone back to wine yet. Not good wine anyways. French started growing good wines and so on. So some details there. So just to clarify that this doesn't mean we are not having global warming. It just is that it's a Greenland warm temperature. So the longer term perspective gives you better picture. Going from the middle of the last ice age, there are several hiccups of melting. So here are the ones. So sudden warming at the end of the last ice age. Younger Dryas here of the refreezing. Dryas is an Arctic flower in the tundra, Arctic tundra. It occurs in cold periods. So if warming happened, then tundra expanded and then suddenly disappeared, then you can use that as a proxy for extension of reglaciation. We can also look at evidences in the ocean for cold water species of phytoplankton and so on, which do exist, but this gives you a clear sense of the relative change in temperatures going into the Holocene. Okay, so you can see now the Greenland temperature mentioned here as the warming relative to the last ice age, but again we have the reference temperature issue here. So if we look at global temperature instead, this is now showing global anomalies with respect to 1961 to 1990. So that's a modern period reference period, not just local Greenland temperature reference. You can see that the Holocene was warmer. We did cool and global warming is now pulling us out of the range of warming we saw during the Holocene. Okay, so don't be confused. Some people have used this to argue that temperatures have been warmer and we are not in global warming and so on, but you should be very careful about whether it's local Greenland temperature or it's global temperature and what reference period you use. For example, if you use this reference period, we would be much warmer. So we have to be careful about reference periods as well. This now shows more clearly, going over the last millennium, multiple reconstructions of temperatures from various different data, sediments, ice cores, tree rings, records, historic records and so on. And you can see that with respect to the industrial period baseline here, we are warming now over, this was in 2000, so by now we have crossed 1 degree centigrade warming. Okay, 1.8 or so degree Fahrenheit. So abrupt climate change then is possible in the system, and they are something to watch out for, because in this warming phase is where ice albedo feedback can kick us into high gear and produce rapid melt of glaciers and sea level rise. Okay. Deep and bottom waters then form in just 4 regions in the North Jin Seas, Greenland, Iceland, Norwegian Seas, Labrador Sea, and Ross Sea and Weddell Sea, and they get mixed up in the Southern Ocean and inundate the Pacific and Indian Oceans and make their way back to the formation sites, and this whole cycle takes hundreds of years to thousands of years. You can see the vertical circulation schematic here. So waters sink to various depths depending on how heavy they are. So North Atlantic deep water is crossing the equator, being pulled up in the Southern Ocean, and the Antarctic bottom water is sinking like a rock to the bottom and inundating the rest of the ocean and so on. So this is what takes down heat. There are other places as well, but heat, oxygen, CO2, other greenhouse gases, CFCs, bomb tritium, bomb radiocarbon, and so on and so forth. Okay, so we will do the observed patterns of climate variability to better establish what we mean by natural variability. We already said natural variability is because of radiation forcing changes from the sun, solar activities, continental movements, volcanic eruptions, and so on. And they happen at various time scales. As we saw the paleo record, they can happen on multiple time scales based on which orbital forcing may be involved in forcing the change. Glacial deglacial cycles are long.